Hi, this is Priyanka Adsmalli. Today we are going to discuss about the topic regarding Mac OS X. Along with that, I need to introduce my friends Ashutosh Jarkade, Anna Muhammad Chowdhury, and Shrivani, who are going to deal some of the topics in Mac OS X. This is the organization of our presentation, which contains Mac OS X system technologies, system architecture, bundles, booting and logging in, process and memory management, file system, finder, software configuration, and finally issues. Mac OS X, Mac OS X system technologies. Regarding the functional perspective of Mac OS X system technologies, it contains four, it is totally divided into four parts. They are the bottom level, which is going to contain the Darwin, it is called as Darwin, uh, which contains the Unix based core operating system. I mean, it means all the operations of kernel is going to be handled by Darwin in Mac OS X system. The level higher about is the windowing and graphic system, which is implemented by the technologies called as Quartz and QuickTime or OpenGL. The graphic systems in Mac OS is highly transparent, and this killer graphics revolutionized the system of computers, personal computers. The level higher above the Windows and graphic system is called as application environments, where all the applications are going to be developed by the developers of Mac OS X system. And Aqua, the highest level of functional perspective is called as Aqua, which is termed due to its transcendence and its water shadowing technology because it is highly crystal clear. This is a human interface design which was behind the user experience. This is the functional view of Mac OS X, which I was described, contains all the four layers. The graphical user interface that brings a computer to life with color, depth, clarity, transparency, and motion. That is, it was highly clear, crystal clear, which was named as a water. That's why the Steve Jobs named the user interface design, which was completely where the user is going to view the system, is named as Aqua. It offers highly richly colored, and photo quality of the icon is adjusted up to 128 by 128 pixels. As it is highly clear and we can recognize each and every element and each and every files on Mac OS X as which were indicated with different kinds of icons. For example, for the sake of files or documents, PDFs, they are going to represent it as some document files which contain some symbol. And similarly, for the sake of MP3 or videos, they are going to represent it with the video symbols like that. It eliminates the problem of proliferating windows by introducing the concepts of sheet and the finder system. That is, for example, if we open several documents at a time, though we open several documents at a time, we are just going to manipulate a single window at a time. Thus the problem of proliferating windows is going to be reduced in the case of Mac OS X. The biggest part of Aqua experience for the users in the design of desktop is the Finder system, the system application that acts as a primary interface for the file system interaction. This is the Aqua user interface, which represents the crystal clear experience of Aqua with different kinds of icons. And the topmost layer contains the Finder, and the downmost layer, which is represented as dock. Application environments. Application environment is the highest layer in the functional layers of operating systems of Mac OS X, which contains the classic, Carbon, Cocoa, and Java environment. The classic is highest compatibility environment, which was run mostly on Mac OS 9 applications, except some features of Mac OS X such as Aqua and core architectural enhancement provided by Darwin. Each and every element that is developed on Mac OS 9 is going to Mac OS X is going to be executed on Mac OS 9. The Carbon environment ensures that the applications that take the advantage of protected memory, preemptive multitasking, and other features of Darwin. That is, this is the layer where we are going to implement the applications. But this is highly involved with the developer. The COCO environment offers the advanced object-oriented framework for creating the next generation applications. This is the environment where the object-oriented concepts are going to be applied in order to develop the applications for the future generations. And Java environment is completely depending upon the pure Java and mixed API of Java applications and applets. Next, graphic and imaging. This is the most important part which makes Mac OS X too ideal in this environment of computer world. Mac OS X is graphically capable due to it is developed by using three powerful technologies, that is Quartz, QuickTime, and OpenGL. Used in the classic, all these three technologies are used in all the environments of applications, such as the classic environment, Carbon environment, and COCO environment, and the Java environment, which is used to create the next generation applications. The Darwin is the core of operating system, nothing but the core of which was completely related to Unix operating system technologies of core level. The core operating system, which is an open source technology engineered for stability, reliability, and performance. This is an integrated technology that contains Mac, BSD, device drivers, support, and networking extensions and file systems, which we're going to describe later on clearly in depth. The design of Darwin is highly modular, so that each and every module which are going to be developed is independent of other module, and there is a higher communication between the modules in order to manage all the applications that are running on Mac. The Mac is the heart of Darwin. It is called as a microkernel. It manages all the processor resources such as CPU, processor resource. Graphics and imaging. This is the most important part of Mac OS X. Mac OS X's graphical compatibility is due to the combination of three powerful technologies, Quartz, QuickTime, and OpenGL. The Quartz again is going to be divided into Quartz 2D and Quartz QuickTime, and Quartz Compositor. Quartz. All these technologies which were used to develop the graphics are used in all the environment of applications such as classic environment, Carbon environment, and COCO and Java environment in order to develop the applications for the next generation. Darwin is the core part of operating system, which was completely open source and was developed based on Unix operating system. It is an integrated technology that contains all the components such as Mac, BSD, device drivers supports and networking extensions and file systems. The design is highly modular, and the first integrated technology that I am going to describe in Darwin is Mac. Mac is the microkernel of Mac OS X operating system, which is called as heart of Darwin. This is because it is the technology which is going to manage all the processor resources such as CPU usage and memory. And it also handles scheduling, enforces memory protection, and implement the message-centered infrastructure for untyped inter-process communication both in local and remote systems. The major advantages of Mac is going to establish the protected memory and preemptive multitasking, advanced virtual memory, real-time support, and it also brings the cooperative multitasking and preemptive and cooperative multithreading into existence during the development of applications. The BSD, Berkeley Software Distribution. The currently used Berkeley software distribution in Mac OS X is 4.4 BSD. The Darwin implementation of BSD includes much of POSIX application programming interfaces and exports all the application layers of the system. BSD serves as a basis for the file system and networking facilities. It provides several programming interfaces which provide services, including the process model, which is capable of doing capable of maintaining all the process IDs, signals, and so on. And the next one is the basic security policies such as the user IDs and permissions and threading. It also supports the threading and BSD sockets. Next, we are going to discuss about the device drivers that are going to be supported by kernel. The Darwin. The Darwin offers the object-oriented framework called as IOKit, which is going to maintain all the features of videos and audio files that we are going to improve. The most important features of IOKit are true plug-and-play, dynamic device management, that is called as hot plugging, and the power management, both the desktop and portables, and networking extensions. The networking kernel extension technology facilitates to create network kernel extensions technology facilitates to create networking modules and even entire protocol stacks that can be dynamically loaded into kernel and unloaded from it. Mac OS X system technologies maintains these NKEs, which makes possible to configure protocol stacks automatically. At the data link and network layers, they can also receive the notifications of asynchronous events from the device drivers, such as when they are in change in the status of network interface. File systems. The file system component of Darwin is based on the extension to BSD and an enhanced virtual file system design. VFS enables a layered architecture in which file systems are stackable. Features. The main features of file system are permissions on removable media. That is, for each and every removable media that we are going to connect to our system is going to have registered with a global unique ID and URL based volume amount, which enables the user to mount such things such as Apple Share and web servers. And unified buffer cache, which consolidates the buffer cache with the virtual memory cache. And the long file names support for hiding file names and extensions on per file basis. Mac OS X must be able to handle file data on many volumes format. The local volume formats of Mac OS X, which is extended format, is hierarchical file system plus, and the Mac OS standard format is hierarchical file system. Along with that, it is also going to support some other extendable formats of volume formats such as UFS, UDF, and ISO 9660. The system architecture. We are completely have a brief idea about the system technologies of Mac OS X. Later on, we are discussing about the system architecture of Mac OS X, which is completely layered architecture that is going to be involved. Mac OS X has 4 distinct layers of system software, such as application environment layer and application services, core services, and kernel environment. These already we have seen this in the diagrammatic representation of functional representation of Mac OS X, where the application environment contains the environment such as 5 applications: Carbon, Cocoa, Java, Classic, and BSD commands. And application services are the services which are provided to develop the graphical user interface with the help of technologies such as Quartz, QuickDraw, OpenGL, QuickTime, etc. And whereas the core services which have no effect on user graphical interface, it includes the core foundation. It includes the following such as core foundation, open transport, and certain core portions of the Carbon. Kernel environment provides the foundation layer of Mac OS X. Its primary components are Mac BSD, as we discussed before, but it also includes the networking protocol stacks and services, file systems, and device drivers. The kernel environment offers facilities for developing device drivers and loadable kernel extensions, including the network kernel extensions. The layered perspective of the Mac OS X is shown as in the following diagram, which contains the lower layer is the kernel, above is core services, above is the application services, and above is the application environment. The application environments, which contains the Carbon, Cocoa, and Java applications, whereas the Carbon is the in adaptation to the kernel environment, features advanced virtual memory and memory protections. Many IPs, particularly the memory manager, which undergoes changes that restricts and eliminates the user zone system memory. It contains Carbon, Cocoa, and Java environments, which contains the the Carbon is going to handle the memory allocations, which was going to handle by the memory manager, such as it is going to eliminate the unused zones and system memory and temporary memories. Whereas in the case of hardware interfaces, the device driver architecture provides by the IO kit and mediates all the lower level access to the hardware devices. Resources. All the resources are going to be managed by the resource manager, which places a greater restriction and accessing to the resource map. Required replacement manager. For example, the quick draw is which is equals to 3D OpenGL. The quick draw is used in Mac OS 9, and whereas 3D OpenGL is going to be used in our Mac OS X. Like that, the required replacement managers are going to be replaced in Mac OS X. And the resources. The resource manager places greater restrictions on accessing the resource map. The next application is the Cocoa environment. The Cocoa application environment based on the two object-oriented frameworks. One is the foundation and the other one is the application kit. The classes in the foundation framework provides the object and functionality that have no impact on user interface. Objects such as the basic programming types, kernel environments, and object-related functionality, file system, and IO functionality. The class of the application kit furnishes all the objects and behaviors that affects what user sees in the user interface, such as windows and buttons and responsive mouse clicks and key presses, etc. The collection of classes for the user interface objects are event handling and application and document management. The Java application environment in Mac OS X has three components, that is development environment, runtime environment, and application framework environment. The development environment contains the Java compiler and debugger, whereas the runtime environment contains the Java virtual machine, just-in-time JIT, byte compiler, and the basic Java packages. Whereas the application framework contains the classes necessary for building the Java applications, and AWT abstract window toolkit and Sphinx are the packages that are going to be included in order to develop the Java applications. The application services. The preeminent application services of Mac OS are those that makes up the graphics and windowing. We are going to develop these applications where the Quartz 2D and Quartz Compositor. This is the diagram which represents the Quartz 2D, which contains all these rendering libraries: Quartz Draw, QuickTime, and OpenGL. And Quartz Compositor is the Windows server. The 2D is going to have its input as any kind of files that is independent, and the destination is a drawing operation, may be the Windows bitmap Quartz Compositor. Quartz Compositor consists of Mac OS X Windows Server and the system programming interfaces it implements. The Windows Server has overall the responsibilities for displaying the windows, including the composition, positioning, and basic management. It also performs low-level cursor management and event routing. It is a video mixer model. The core services layer contains the system services that do not have any effect in the graphical user interface. The levels include the core and foundation, core, Carbon core, CF network, web services, and open transport. Whereas the core foundation belongs to the core foundation framework package, and all the other four belongs to the core services framework package. The core services. In the core services, the core foundation framework, which contains all the application services that are going to be developed in the application environment and also the applications in themselves. Advantages, which increases the capability of sharing code and data among the frameworks, libraries, and applications in different environments. And Core Foundation also enables easy internationalization using Unicode strings and provide abstraction that contributes to operating system independence. Core Services Framework, Carbon Core. It includes the number of Carbon managers that offer services such as cooperative and preemptive threading, resource management, memory management, and file system operations to all the application environment. CF Network and web services belongs to the core services. The preferred API to use for the user level networking and communications, which is used to pass the message protocols between the clients and servers. Web services, which takes the advantage of remote programs on the internet and the local intranet. Web services are used the standard protocols such as Simple Object Access Protocol and XML RPC to communicate services requests over HTTP. The Web Services Core Framework defines an API for sending requests to remote servers using these protocols for handling responses. And next, we are going to describe the Open Transport, a carbon compatibility API that provides the legacy networking and communication support. It enables the applications to use more than one networking system at once. AppleTalk to communicate with network printers and TCP/IP to connect the internet. With Open Transport, user can save and modify different networking configuration and easily switch it. Bundles. A bundle is a directory in the file system that stores executable code and software resources related to that code. Mac OS X recognizes three distinct types of bundles. One is application, framework, and loadable bundle. Application bundles always extended with .app extension, and the framework extended with .framework extension, and loadable bundles extended with .bundle extension. The loaded bundle again divided into two types, which are palette and plugin. The palette is used to develop the interface builder, and whereas a plugin is a special type of loadable bundle that requires the architecture and implementation beyond the simple code loading and function lookup functionality of the regular bundle programming interfaces. The bundles. Advantages of the bundles. The single bundle executable can run on Mac OS 9 and Mac OS X. Support multiple chip architecture and library architectures. Can index and access help files and other bundle information resources through Sherlock and Finder. Can install, relocate, and remove bundles simply by dragging them. The single bundle can support multiple languages through an internationalization architecture. The later concepts from the booting and login is going to be handled by Mr. Ashutosh Jarkade.
My name is Ashutosh, and I am going to explain the next part of the operating system, which is the booting and the logging process. Booting up refers to the series of actions that system performs and prepare itself for the use. Without booting, system cannot prepare itself for operations. And the booting sequence includes several different tasks. Without that task, the system cannot boot into the operating system. And those tasks including some kind of hardware initialization, system starting, starting system demos, and displaying the login window. For the booting, we require some kind of there are some sequence for booting all this process, and we are going to discuss on the next slide about the booting and the sequence of the booting process. So whenever the Macintosh system is powered on, there is one hardware from their part, which is the boot ROM, which does the two things. But the first process is the post process, and the post process means that it is the power on self test. The post process checks all the hardware devices installed on the system. It will check the RAM, it will check the hard disk, it will check the all other input output devices whether they are working or not. If some part of the operating system is not working, then it will it won't start, and the power on self test will fail, and the system won't start. And after the successful initialization of the power on self test, it will give the control to the bootloader. The bootloader will it does two things actually. If the disk has been encrypted, then it will ask for the password for the encrypted disk. Otherwise, it will give the load. It will load the kernel environment. The bootloader loads the kernel drivers, and it loads the kernel extension. After loading the bootloader, it will give its control to the kernel, and kernel will initialize the procedure. After the initialization process, the system will go into the system initialization process. The system initialization process starts to run the system startup process. The items and it launches and the system demos. The startup items and any application run prior to the login window application from the group of the system processes. The init process on every other process on the system. The system initialization process contains two things: the RC boot and the RC script. The RC boot and the RC script are performing the basic task for the initialization of the systems, and the RC script starts the device driver loader, it starts the ATS server, and it starts the Windows server. At the final step, RC starts the server system program and to process the local system startup items. The startup items include some of the basic programs which the operating system required. So without these basic programs, it cannot it cannot go into the operating system. So the core system that startup items require are the system tuning. The system tuning is a program that set up the performance value. Some of the other core system startup items are like the disk, AppleTalk, Samba. Samba is a kind of a startup program that start the Samba server, and the network program is a kind of a program that configures all the local network through which you can connect to internet or local LAN servers and all these things. Coming to the logging part of the macOS system, so logging part, it includes for logging into your system, macOS systems, you need the username and the password. It is a kind of authentication for accessing the operating system. So the logging part contains the two parts, the logging and the authentication part. Coming to the logging, except the authentication, it will do some kind of other jobs. Likewise, it loads the user computing environment, like if you set some kind of theme or some kind of environment that you want to that you would love to work on, it will load the environment for the user according to their requirement. It launches the dock, the Finder, and the system UI server. It launches the setup assistant if any installation is in progress. It automatically launches the application specified in the login item system preferences. When all of the specified applications are launched and running, the login procedure is then completed. Moving to the authentication, the user logging out. The user authentication required prior for the accessing the system. The login window applications take the user information and passes it directly to the service for authentication. The typical logout, restart, shutdown procedure proceeds as follows. The user first given the username and then the password. If the password and the username does not match the system, it will not authenticate for the user to access the system. Otherwise, if the system matches the password and username, it will allow for the authentication. So this is my part for the logging and the authentication and the booting process. The next part will be going to be explained by the other members.
Hi, my name is Amit Chaudhary. Now I'm going to brief on process management. So in process management, there is a C thread package, which is a user level thread library built on the top of Mach primitives. Actually, this library has some mechanism that can handle the library file. So there's a major influence on POSIX thread standard, and in thread control, it create and destroy thread. And also it waits for a specific thread for terminate, then continue the calling thread. And there is a mutual exclusion using spin lock only. So it is actually it is some kinds of spin lock topology, and also it is a condition variable. And in running loop, if we see the pictorial view, like it has got start, run unit date, handle port, custom source, my select trend, timer fired at end. So also it is connected with timer source. And now I'm going to discuss the process management CPU scheduler. Only thread are scheduled and tasks are ignored over here. Also in dynamic thread priority number, it has got 0 to 127. And also in dynamic thread, the lowest priority thread is one with the most recent large CPU uses. Also it uses priority source thread into one of 32 global run QE. Also in here there is no central dispatcher, and processor console run QE to the select next thread, the local QE first, then the global QE come in the processor. And in optimization, thread time quantum varies inversely with total number of thread but constant over the entire system. Also in process management, there is one option called exception handling. Implements a global cross-task exception handling system, and also used to emulate BSD style signals, and it supports execution of BSD program. And in Mach port, we can see the method on kernel object invoked by a message, and it also enables a thread to send data to another thread in a controller manner, and in kernel protected, implemented as a bounded QE. Also it sends and receives writes. Also over here we can see a sending message to port will result in the receiver task getting the message, and it is task and corresponding port can be migrated to another computer with the same machine architecture. And interface communication message, here there is a defined header and plus one or more type of data object is added during the header, And in header content, destination port name, reply port name, and message name is add to this header content. In the line message data content, simple type port writes. Out of the data pointer, we can see there's a via virtual memory management, use copy on write, and spares virtual memory. If you see the picture, there is a port, message queue, message, and in the message header, we can see the destination port, reply port, size, operation, queue, type data, and so on. Now I am going to discuss memory management and IPC. Actually, MAC connected memory management and communication IPC by dialing each to be used in implementation of the other. In memory management using IPC based on the memory object represented by a port or ports, IPC messages are sent to those ports to request operation on the object. In IPC using memory management technique, we see messages are passed by the moving pointer to the shared memory object. Also in programmer interface, we see, it is called system level call. It is actually based emulation in the kernel in 2.5, not really in the microkernel, externalized in 3.0. Also in here, up calls made to libraries in task address space and server. And in C thread package, we can see in C language interface to MAC thread primitives. And in MAC IO system, we see that memory object used for mapping device to memory, handling user level process, and non-memory map device handle in microkernel. And device are memory objective actually. And now I am going to tell about specialized version of MAC kernel. MAC is a general purpose specific version with a machine dependent feature may need. Example, Norma, no remote memory access. In a short, we call it Norma, multi-computer with fast interconnected hardware, need for faster interposes communication solution. MAC 3.0 implement functionality similar to net message server direct in the kernel. And also it provides much more efficient internode IPC. So now I am going to tell about the file system in Mac OS. So here we can see this is the data in storage, like all the binary system 0 and 1 are stored in the hard drive. So MAC file is a data fork, actual data, only meaningful part of Macintosh file on non-Macintosh system. In resource fork, as we can see, it is nothing the collection of attributes or value pairs or text data fork and embedded images like resource fork. And over here we see the finder and the savior of MAC. So we are going to discuss like default file manager, explore files, and launch application. MAC file systems type, like we can see, we can categorize as the local file system which uses the locally attached storage. Example, HFS plus, HFS, NTFS, UDF, and UFS. Also in network file system, there is a different type of terminology and topology they are using, but over here Apple Filling Protocol, FTP file, and NFS. In Mac file system, it is called Presidio file system, which non-conventional file storage, no dedication disk block. Example, CDDAFS, DEADFS, and DVDFS, etc. In Apple cluster file system, it is shared SAN file and family of XN product. And local file system, as we can see, introduced with Macintosh computer in 1984. File stored as single directory, flat file system, illusion of hierarchical view using Finder, introduced resource fork, which is stored structural data, and in metadata, it supports graphic user interface GUI of Mac OS. And Macintosh, actually now I am going to discuss Macintosh OS X Basic. So here, as you can see the pictorial view, like if you double click on hard drive icon, it will display the content window, like you can see the hard drive icon, CD icon, document icon, and so on. And also in Finder desktop menu bar, if you click on Finder, you will see the pop-up menu will pop up and it will show the the menu bar. Also display state of the file, you can click the right side and it will pop up the state of the folder. And in Macintosh OS docs, if you see the beneath the Macintosh window, you can see that there is a doc display application, folder file function icon on the leftmost side of standard application in Mac OS X. If you click on Macintosh window, Mac window used to locate and modify files and folders. Like as you can see in the picture, there is a minimize button, close button, back and forward button, and also the view icon button. you can change the view in Mac OS, and also there's a hide and restore toolbar which you can hide your file or restore your file and so on. In Mac window option, as you can see, it has located the edit and organize file and folder of various media on your hard drive and device. Like there's a storage device, there is a desktop, home, private, media storage, and quick look. Also you have a search button in the right side. Also, to display the icon description, you need to click on toolbar with Ctrl plus click. Apple Finder and File menu. The Apple menu provides application and system information and the shutdown function. Also, the File menu create a shortcut and new folder, retrieve file information, eject drives, and burn your CD. In Apple Finder File menu, you can see if you click on the Finder menu bar, you can see a couple of options here, like the Apple icon. If you click, you can see the about this app, Mac, software upgrade, and so on. And if you click on Finder, you will see the about Finder, performance, preference, empty, trash, and so on. And in File, if you click on File, then you will see the new Finder window, new folder, and so on. So it is pretty much easier to access and navigate this menu bar system. Also, if you wanted to do some edit and Windows menu, there is some command like you can see the menu display and arrange files and folders, and have the customized toolbar function. And there's another option called Macintosh Go menu. In the menu, the Go menu allows navigating to any location on the computer, internet, or network. For example, if you have any network resources or any other music share drive, you can view from here. And in application menu, you can find lots of application, like for example Photoshop, Eclipse, and so on. And in system preference, you can see the Apple menu will allow you to make modification within your computer, like adding hardware, adding and removing program, updating application, and so on. And there is the Macintosh view, like if you click on it, and you can see the cover flow view over here, and there's a column view. Also you can there is another option called creating directory or folder using Mac OS. So you can create a directory and folder by using the title bar display command. And also in Mac OS, it is pretty much easier to copy folder and file from one place to another. For example, if you see the picture view, then you can see how it is easier to copy and read from folder from your CD. And creating allies or shortcut windows, as you can see, it is easier to create a shortcut windows in Mac. And if you organize your desktop in an efficient way, you can organize like this way. So here is the quick look of your Mac OS. So this is all about my part. Now my next friend is going to cover the next part. That's all about.
Hi, my name is Srivani. I'm going to explain about the software configuration and the issues. Mac OS gives you a number of ways to configure your software. It stores in various mechanisms. The mechanism permit dynamic updating of this data and makes available the programs at runtime. And we have a basic configuration option, property list, where it can be a form of data using XML as a structuring media. Elements of the property list may be such as type like arrays, dictionaries, and string. And system routines allows programs to read property list into the memory and convert the data into a real data. And information property list, here is a special form of property list where we have a basic bundles, attributes, and information of interest to Finder and other application. The information property list is stored inside the bundle. It specifies information such as document type, URS, copyright, and version information. And the information property list allows the specification of user-defined keys. Preference system, and here it allows to create, write, and read as per the user, application, and a host. And here the user preference is they are not critical. If they are lost, the application should be available to recreate and default set of preference. You should not store an application initially configuration data as a preference. because this is very important here. Initial configuration data is critical and it should be stored in the information property list or some other property list stored inside the application package. We have some issues in the Mac. First is task and process. In this task and process provides an important case is like we have Mac task, BSD process, Carbon process, and so on. In Mac task, it defined as an open software foundation where is a container that holds a set of threads. In other words, the Mac task in Mac OS X is a manager memory, address space, and other resources related to the execution of this thread. Threading package is nothing but it's an execution within the process. It associated with all stack and the process state. A thread states the virtual address space, resources, and thread of the process. The kernel environment of the Mac OS, especially a Mac, provides a fundamental thread support. A Mac maintains the register state of its threads and schedule them to related to one another. We have a inter-process communication where the application should be preferred Apple elements over the other method for most inter-process communication on Mac OS X. Distributed notification can be used to broadcast simple notification all the application on the same machine. Like call may be synchronous, meaning sending process is blocked while waiting process for a reply, or asynchronous because the meaning no reply is expected when the sender is not blocked. And we have BSD sockets for communication over a network. BSD pipes can be used for a one-way communication on the same computer. BSD signal is invoked by the kernel to communicate to a process. Here we can see that the BSD signal, how it can be handled. Signals are complex to use efficiently. They tend to behave differently in different operating system. So if a single namespace and it has a single integer, though it collides with a third party member, as such as signal should be generally avoided for normal inter-process communication ends. And we have sharing large resources with a shared memory. When a data structure is shared memory is corrupted, all the process which refers to the data structure is also corrupted. For this reason, shared memory is the best use as a raw storage of data. So with the controlling data structure through all the inter-process communication. And this is we gave a presentation on MS Mac operating system. Thank you.
Priyanka Arsmalli. Today we are discussing about the topic Mac OS X. And I'm also introducing my friends Ashutosh Jakade, Anna Mohammed Chaudhary, and Srivani, who are part in this project. And this is the organization of the project, which we are going to discuss all these topics in the project. The first one is Mac OS X system technologies. Next, system architecture, bundles, booting and logging in, process and memory management, file system, Finder, software configuration, and issues. Mac OS X system technologies. In the functional perspective, the most important concept of Mac OS X comes with Darwin, which is the lowest layer and the core part of operating system. Above that, we are going to discuss about the killer graphics, which is built up with the technologies like Quartz, QuickTime, OpenGL, and above that, an application environment which contain the environments which are of Classic, Carbon, Cocoa, Java, and the Aqua. The final Aqua is the human interface design, which is behind the user experience. Ashu, I need a pause. Here in the next slide, we can see all the parts, the functional view of Mac OS, where Darwin is the lowest layer. Above that,
the layers above that, the graphic environment and windowing layer, which contains the technologies like Quartz, OpenGL, and QuickTime. Above that, the application environment, where we are going to utilize our graphic technologies in order to apply in the application environments. And Aqua is which is highly transparent and which was completely designed for the user perspective, and which was made up of with water shadow.